Okay, so good evening all. Today is the good evening all. Today is the last week for the doubt clearing session. Um, so in today we will study about the overview of the fatigue of metal matrix composites. So let's start. So fatigue of metal matrix composites. So generally, as we know, the composites have the combined and increased properties, increased and higher properties compared to the matrix and reinforcement. So the fatigue life and fatigue strength is also increases in of the after the manufacturing of the composite. So fatigue life of composites is higher. Because the cyclic saturation stress of the composite is also high. So if we take the example of an aluminum alloy metal matrix composite, that is 2219, the temper condition is T5. No, in which the 15% titanium carbide particles are reinforced. So if we compare the fatigue properties with of this composite with its matrix 2219, so if we draw a curve between this is peak stress in ampere, and this is the number of cycles, and this is 2n. And the property will also differ by variation of the aging process. Means if aging is done artificially and naturally, that will affect the fatigue behavior of the composite. So for the unreinforced good evening, Moni.
Good evening, madam.
You came back after very long time.
Yes, madam.
Okay, so are you following my all lectures which I uploaded?
यस मैडम, मैंने सभी लेक्चर है वो स्टडी कर लिए।
हाँ
लेक्चर नंबर 4 में मेरा एक डाउट है, जो ग्रेन ग्रोथ थियरी है ना,
हाँ हाँ
हाँ वो एक बार आप एक्सप्लेन कर देना। और सेकंड है क्रैक ब्रीजिंग,
क्रैक
जो
ब्रिजिंग।
क्रैक्ड, हाँ
हाँ
क्रैक टेपिंग है वो सब क्लियर है, लेकिन जो क्रैक ब्रिजिंग है वो पता नहीं चलता है।
हाँ।
तो ये दोनों डाउट है। और एक थर्ड क्वेश्चन था, क्या यदि हम एल्यूमिनियम मेटल मैट्रिक्स कंपोजिट है एज ए पीएचडी टॉपिक में लेना चाहते हैं, तो उसमें तो ये बेसिक थियरी वर्कआउट होगी या हमें उसकी स्ट्रेंथ आइडेंटिफाई के लिए यूज करना पड़ेगा?
कैन यू एक्सप्लेन इट अगेन?
मैडम,
हाँ।
जो हमारा ये मूक की जो ये ट्रेनिंग है एल्यूमिनियम मेटल मैट्रिक्स कंपोजिट, तो इसमें हमने क्या किया है, जो बेसिक मैकेनिज्म है
हाँ।
कि एल्यूमिनियम मेटल मैट्रिक्स कंपोजिट में उसकी स्ट्रेंथ कैसे आती है, जो बेसिक मैकेनिज्म फंडामेंटल है वो स्टडी किया है। तो इसके ऊपर हमें पीएचडी में टॉपिक सिलेक्शन करना है तो हम कर सकते हैं।
हाँ, कर सकते हैं।
अच्छा मैडम, तो इसमें हमें पीएचडी फॉर एग्जांपल मैंने टॉपिक रखा है जो हमारे जो फंडामेंटल मैकेनिज्म है उसके वो रिलेटेड, तो हमें पता कैसे चलता है कि बैकग्राउंड में ऐसी ऐसी इफेक्ट आती है, स्ट्रक्चर में ऐसा चेंज आता है, जो स्ट्रक्चर चेंज आता है वो हम माइक्रोस्कोप में स्टडी कर सकते हैं, या हम स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोप है तो उसमें हम स्टडी कर सकते हैं। लेकिन जो क्रैक प्रोपोगेशन की जो फंडामेंटल इफेक्ट आती है, फॉर एग्जांपल के एल्यूमिनियम कंपोजिट है तो उसमें हम टाइटेनियम रिइंफोर्समेंट है
हाँ,
या सिलिकॉन कार्बाइड है वो हम ऐड करते हैं, तो उसकी जो इफेक्ट आती है तो हम कैसे पता करें?
इफेक्ट आती है वो हम पता ऐसे करेंगे जब मैकेनिकल टेस्टिंग करेंगे तो उसकी स्ट्रेंथ हायर होगी। एंड जब वाया लाइक सॉरी एनर्जी डिस्पर्सिव स्पेक्ट्रोस्कोपी जिसमें केमिकल कंपोजिशन वी फाइंड, सो ईडीएस कर सकते हैं। ईडीएस एंड ईपीए से हमें पार्टिकल्स मिल जाएंगे। एंड जब मैकेनिकल टेस्टिंग करेंगे तो हमें जो उसका मैकेनिकल बिहेवियर है वो मीन्स बेटर होगा एज कम्पेयर टू द एज मीन्स प्योर अलॉय।
ओके मैडम। और एक क्वेश्चन और था, राइट नाउ अभी मेरा क्या है, पीएचडी स्टार्ट हुआ है 2023-24 में, मैंने लास्ट ईयर एडमिशन लिया था जीटीयू में गुजरात से।
ओके।
तो अभी जो मैं सोच रहा हूँ मेरा पीएचडी के टॉपिक के बारे में, तो वो एल्यूमिनियम मेटल मैट्रिक्स कंपोजिट है। उसमें उसकी 6063 कंपोनेंट है एल्यूमिनियम
ओके।
एलोय,
हाँ।
उसमें सिलिकॉन कार्बाइड है,
हाँ।
वो ऐड करके उसकी जो है स्ट्रेंथ आइडेंटिफाई करना चाहता हूँ। तो उसमें मैं कुछ एडिशन कर सकता हूँ मैडम, स्ट्रेंथ
एडिश
के अलावा? उसमें मैकेनिकल प्रॉपर्टी
हाँ।
मींस टफनेस है, हार्डनेस है, टेंसाइल स्ट्रेंथ है और वियर रेजिस्टेंस प्रॉपर्टी है,
हाँ।
ये सब
एंड
इम्प्रूव करना है,
और
कितना
फैटिग
इम्प्रूव होता है?
स्ट्रेंथ। हाँ। हाँ, ये सब इम्प्रूव
यस।
होती है, मतलब फैटिग स्ट्रेंथ भी इम्प्रूव होगी। एंड टेंसाइल हार्डनेस और मतलब जैसे सिलिकॉन कार्बाइड हम ऐड करते हैं तो उससे ग्रेन रिफाइनमेंट होता है। विच रूट यू आर फॉलोइंग फॉर मैन्युफैक्चरिंग ऑफ द कंपोजिट?
लिक्विड स्टर कास्टिंग मैडम।
लिक्विड स्टील कास्टिंग। ओके। Yeah, so yeah, you can add the silicon carbide. So the silicon carbide will act as the heterogeneous nucleation, na? So it will it will refine the grain size. So the direct impact of the grain size will be on the hardness and tensile strength. And as the tensile strength increases, the fatigue strength also increases. एंड उसमें
ओके।
हमें डक्टिलिटी का भी एक फैक्टर देखना होगा कि डक्टिलिटी डिक्रीज हो रही है विद एडिशन ऑफ सिलिकॉन कार्बाइड और इंक्रीज हो रही है।
ओके मैडम।
तो जैसे
एंड
डक्टिलिटी और स्ट्रेंथ का जब हम ऐड करेंगे तो उससे फिर हमें टफनेस मिलेगी, क्योंकि उसमें डक्टिलिटी मीन्स फ्रैक्चर टफनेस के लिए हमें मतलब प्लास्टिक डिफॉर्मेशन चाहिए। तो स्ट्रेंथ एंड डक्टिलिटी दोनों देखनी है। मीन्स स्ट्रेंथ इंक्रीज तो होगी पर डक्टिलिटी डिक्रीज तो नहीं हो रही, वो देखना है।
ओके मैडम।
सो इट्स उसमें एक फैटिक क्रैक ग्रोथ थ्योरी समझाना है और क्रैक ब्रिजिंग
हाँ
बताना है।
हाँ यस मैडम, जो इसमें 3 स्टेप आते हैं, स्टेप 1, स्टेप 2, स्टेप 3, जो
हाँ
ग्रीन ग्रोथ थियरी। हाँ यस मैडम।
ठीक है।
ग्रीन ग्रोथ नहीं मैडम, यह क्रैक प्रोपोगेशन थियरी मैडम, सॉरी, क्रैक
क्रैक
प्रोपोगेशन थियरी।
हाँ क्रैक प्रोपिगेशन थ्योरी। हाँ तो इन दी क्रैक फिनोमेना। हाँ तो क्रैक ग्रोथ थ्योरी मैं स्टार्टिंग से या तो समझाती हूँ तो।
यस मैडम, ओके ओके मैडम।
ओके। सो कैन यू सी माई स्क्रीन?
यस मैम, विजिबल।
ओके। So the, as we know, the crack growth region generally comes in the uh, uh, second stage 2 of the crack growth rate versus fracture toughness graph. Like this is for delta K, means stress intensity factor, and this is dA by dN. So this is the crack propagation rate. And this is stress intensity factor. So in this curve we get the sigmoidal type of curve. So the first region decides the threshold stress intensity factor, below which no crack will propagate. So this is stage 1, this is stage 2, and this is stage 3rd. So the the delta K value at the stage 3rd when the sample fractures can be represented as the fracture toughness of the material or composite. And the stage 1, stage 2 consists follow uh, follow a relationship of the crack growth rate with the intensity factor as C delta K power raised to m. So this the slope of this region will decide the crack propagation rate and the material behavior. So this is delta threshold. So the intense uh, stress intensity factor can be written as the K max minus K minimum, and we know that the K is written as the sigma root pi a. So if we write this equation, sigma max root pi a, so this delta K can be written as the sigma max minus sigma minimum. So means the stress intensity factor is directly proportional to the stress. And if we write the stress ratio, means sigma, sorry, K minimum divided by K max maximum, and this can be written as the sigma minimum and sigma max. So the microstructure and the reinforcement effect is generally less influence in the stage 2, but in the stage 1 and stage 3 the microstructure and reinforcement will affect. So the and also the stress ratio also define. So the means the crack growth rate is also dependent on the stress ratio. So if a test is done at constant by keeping the stress ratio constant, approximately r raised to power 0.3, means why we choose the 0.3, because as the stress ratio is more positive, the fatigue limit will also be higher, and in the presence of reinforcement.
मैडम
Yes.
ये जो रेशियो है 0.3 ये स्टैंडर्ड है?
नहीं, स्टैंडर्ड नहीं है, वी अज्यूम फॉर अ टेस्ट.
Okay, majority case we assume R equal to 0.3.
No, for major cases we use the -1, or
Minus 1 R equal to
0.1.
Okay, madam.
Means we are taking the ideal case where R is positive. So for positive R value, the fatigue limit will be higher.
ओके मैडम. और मैडम ये जो डायग्राम आपने ड्रॉ किया था अभी,
हाँ.
तो ये तो कॉमन है ना?
कॉमन है.
फॉर एल्यूमिनियम के लिए है या
ये composite-
कंपोजिट मटेरियल एल्यूमिनियम कंपोजिट के लिए है?
ये अभी कॉमन है, मतलब दोनों के लिए कॉमन है. फिर उसमें वेरिएशंस आते हैं विद रिस्पेक्ट टू द वॉल्यूम फ्रैक्शन ऑफ पार्टिकल्स. अभी यहाँ पे कंपेयर नहीं किया है मैंने. अगर ये हम एज ए रो अलॉय लें या फिर कंपोजिट, तो अगर कंपोजिट का देखेंगे तो उसका मतलब नहीं, अगर इफ़ वी कंसीडर दिस फॉर कंपोजिट, देन फॉर अलॉय द कर्व विल बी मीन्स less steep. This type of curve we will get for the
Okay.
and this is for composite. Means for composite the uh, slope of this second region will be higher. Means the m value will also be
Okay.
high for composites. So only the slope and the trend of the curve will change with the composite, but the region will be same. Yeah, so for a constant R value 0.3 and presence of reinforcement, the threshold will be high. Means the delta KH is high. Means for the same crack length, the alloy will fracture easily, but the composite will not fail. Means the threshold value increases for the composite. And second point is the steep Paris region. Means the stage 2 region is generally called as Paris low. So the Paris region will also get steep. Means the slope will be higher. And third point is the transition to unstable fracture at lower delta K. Means for some cases the fracture toughness of composite can also reduce. So the transition to unstable fracture means, yeah. Transition to unstable fracture at lower delta K, because the elastic and plastic deformation uh, get differ in the composite. Means the deformation is localized and constrained because of the presence of the reinforcement particles. So because of this, the deformation will be non-uniform, so that lead to the unstable fracture, and the fracture will also be at lower delta K value. So there are three types of cases where these 3 points are included. So first case include the means the higher delta KH value, an increase in delta K threshold value, and increased dependence of growth rate on delta K, means M is also high. Second case where the delta KTH value is lower and the M is high. And third case is the where both delta KTH is low and M is also low. So the first condition can be seen in the 2080 aluminum composite with 15% silicon carbide. So if we draw the curve for the growth rate versus intensity factor, yeah. So this curve is for the 2080 alloy in T6 condition, and this curve is for the composite. So here the delta KH value is higher than the alloy, and the slope of this curve in the second region is also higher for the composite. So here the delta KH threshold value and the slope values both are high for this alloy. And if we see the second condition where the uh, threshold value is low and slope is high, so this condition will apply for the aluminium 3.5 copper silicon carbide composite. Yeah, so first condition was for the R equals to 0.3. This ratio is here sorry 0.3, and for this case the stress ratio is 0.1. And the delta KTH is low and M is high. So if we see the curve, is high. So this is for unreinforced alloy. And as we add the silicon carbide, so the curve will shift upwards and to the left. Means the slope is increasing, but the delta KH value is decreasing. So this is with the addition of silicon carbide. Means silicon carbide percentage is increasing from right to left. So for this aluminium 3.5 copper silicon carbide composite, the delta K threshold value is decreasing while the slope of the Paris region is increasing. And for the third region, means where both threshold value and slope is low, and stress ratio is 0.1. So this condition apply for the 7000 series alloy, means aluminium zinc. So the composition is aluminium 9% zinc, 3% magnesium, and 2.5% copper with 15% silicon carbide particles. So for this composite, the graph of the growth rate will be this time. So this curve is for composite, and this is for unreinforced the alloy. So of the composite has the low threshold value and low slope, means it has the less dependence on the stress intensity factor. No, not less dependence, means the growth rate is decreasing less with as in for the low M value. So these are, as we know, the silicon particle reinforced composites are also known as the discontinuously reinforced metal matrix composite. Means DRMMCs. So the crack crane can grow by the different steps. So in which the crack tip phenomena in DRMMCs are explained as the crack closure, crack bridging. Means the why we are taking the crack tip phenomena, because the growth will depend on the sharpness of the crack tip. Means it will get blunted with the growth rate, or it will maintain the sharpness. So the different phenomena occur with the crack. First is the crack closure, second is crack bridging, third is crack deflection, and fourth is the crack trapping. So for the why crack closure happens, so in this case the stress intensity factor uh, work as the driving force for crack closure, and the shielding of the crack tip. So the stress intensity factor K is the driving force, and the crack closure is done by crack shielding of crack uh, by the contact made between crack surfaces. So the crack can close because of the formation of oxide layer on the crack faces. So the formation of oxide layer can close the crack tip, and by the closure the crack will not propagate further. And this is the and if the some asperities are form on crack faces, so this is the roughness induced closure. Means if the roughness of crack surfaces are higher, so the crack can close because of this also, crack induced closure. So the contribution of crack closure to crack tip shielding decreases at high stress ratio. Means, because the at high R the other phenomena will affect the crack growth rate. So for the low R value, the crack shielding will generally done by the crack closer, and for so for low R value, the crack closure will happen, and for high stress ratio, the crack trapping and bridging will happen. Means it is depending on the stress ratio value. So if the R value will change, so the phenomena for the crack growth rate will change. So for at low stress intensity factor, low delta K value, the reinforcement particles hinder the crack advance. Hinder the crack advance or crack tip. Means the reinforcement or the reinforcement already hinder the crack tip to propagate further, and the crack trapping is directly proportional to matrix yield strength. And the square root of particle size. So particle size can be written as the d, and for higher K value, means for low low stress intensity factor, the crack trapping will occur, and the trapping will happen because of the hindrance of the crack tip, because with the reinforcement, because of the reinforcement. So for higher delta K value, the uncracked ligaments in front of the crack tip will form. Means the uncracked ligament, we can assume that the uncracked region ahead of the tip. So because of the uncracked ligaments, the particles which are larger in size. So generally the crack trapping is all inversely proportional to the particle size. Means if for small particles, the crack trapping will happen, while for larger particle size, so for larger particle size, the load will overlap two cracks. Overlap the crack, and this lead to crack bridging. Means as the larger particle fractures, so the because of the fracture of the larger particles, the load will directly will will be on the crack. So due to the overlapping of load on the crack will bridge and it will close. So that will reduce the crack growth rate. So Monir, did you understand the bridging
Yes, madam.
method? Means for the smaller particles the crack trapping will happen, and if the larger particle size means when the larger particles fractures, so because of the fracture the load will impact on the crack, and it will close the crack, leading to the crack bridging. And one more thing happens here, like for generally the larger particles fracture and distribute into fragmented pieces, but if there are fine particles present, and we can say the fractured larger particles also. So fine particles are distributed within the composite. So this the fine particle distribution in the composite will lead to the coplanar array of bridges. And generally the particle fracture lead to the crack bridging. And the frequency of the particle fracture also depends on the stress K max, means maximum stress intensity factor, and the particle size. And if we talk about the crack trapping more, so trapping arises due to deflection of the crack around the particles. So because of the crack deflection, this will lead to a more tortuous crack path. Means we can see in the fractograph of the fractured surface. So the if the or the tortuous path can also be seen by the naked eye. Naked eye. So means if the surface is more rough, and uneven, so means the crack path is tortuous, and so when the surface are more rough and uneven, so that will be the tortuous path, and that can be seen by the naked eye of the fractured by on the fractured sample surface. So due to the more tortuous path, the crack growth rate will reduce because there are the more deflection. Because crack deflection. So if the so this is for the lower crack growth rates, means here crack growth rates are low, and for mid-range growth rates, sorry, the low, this will this corresponds to the stage 1 crack propagation. Means here we can see in this region, so the initial crack propagation case will depend on these all, means crack breaching, crack deflection. And for the mid-range growth rates, means we are considering the stage 2 region, means Paris region. So the crack growth rate depends on the stress intensity factor. So generally for metal matrix composites, the M value increases, means higher so for the mid-range growth rates, the MMCs have have the greater dependence on delta K. And the M value for the metal matrix composite is the 4.226, while for unreinforced matrix, the M value is generally 3 to 4. So in the mid-Paris region, the static fracture mode generally exists. That will lead to first particle fracture and due to void nucleation between the matrix and particle interface. So the particle fracture with the high growth rates means when the growth rates are high, crack growth rate is high, so particle will fail in the stage 2. And for the lower crack growth rates, the crack bridging is generally observed. Means for the higher growth rate in the mid range, the particle fracture, and in the lower crack growth rate, the crack bridging due to particle fracture. And if we see the effect of microstructure, so the microstructure of the composite will differ because of the particle nature, the volume fraction of particle, and size and shape. So this effect comes because of the volume fraction, size and shape of the particle. So if the volume fraction is high, the fatigue life will also increase. So in a stress controlled condition, means high cycle fatigue. So with the increase in volume fraction, the fatigue life will increase in the high cycle fatigue testing. So the high cycle fatigue testing can generally be done on the rotating bending fatigue testing, and the axial loading. And this is the volume fraction effect. And if we see the size effect on the microstructure, so for the 2124 alloy in T6 condition with silicon carbide particles, this composite, so the fatigue strength increases with the decrease in particle size. Means if we draw the curve, this is fatigue strength, and this is particle size in micron. So this behavior means with increase in particle size, the fatigue strength will decrease. So why the fatigue strength decreases? As the particle size increases, the distance between two particles are higher, so the slip length will for this higher distance will increase. And if we see the opposite case where the particles are small, the distance are small between two particles, that will lead to decrease in slip line, decrease in slip length. Slip length means the Berger vector will be low, and for Berger vector the strain energy will be of low. So that will lead to the increase in fatigue strength. And the decrease in particle size also affect the grain refinement. Means for smaller particle, small particles, the grain refinement will be higher, so the grain size reduction will lead to strengthening, and due to strengthening, the tensile strength and the fatigue strength both will increase. Will be high. So the next is the, so we studied the low growth rates and mid-range growth rates. So now we will discuss about the near threshold growth rates. Means the growth rate near the threshold value. In this, if we check this curve in near this region, so near threshold, if the particles are small size, So the small particle size has the detrimental effect on the threshold value, means the small particles will reduce the threshold value. And also the near threshold growth rate. And for larger particle, so the larger particle near threshold region will increase the chances of crack closure. And crack closure chance increase, that lead to better fatigue life, leading to so generally the growth rate decreases, means the resistance to crack growth increasing. So when the resistance to crack growth increasing, the fatigue resistance also increase. And lead to the higher fatigue life. And the crack growth resistance can be increased. So the resistance to crack growth can be increased by volume fraction of particles. If we see for the 7000 series alloy, aluminum, zinc, magnesium, copper alloy with the 15 to 20% silicon carbide particles. So this composite will have the crack growth behavior like this. So this is for this is for 30% silicon carbide, and this is for 20% silicon carbide. Means for the increase in volume fraction, the crack growth is decreasing, means the slope is this type, means for this curve slope is high, for this slope is low. So with the 30% addition of silicon carbide, the crack growth is reducing, so the fatigue strength is higher for 30% silicon carbide composite. And if we see the aging effect on the fatigue strength or fatigue crack growth. So aging effect generally is less. So for only if we see for 30%, this curve can be drawn for the aged condition, means it can be underaged or overaged. Similarly for the 20% silicon carbide, the aged change will be very less. So this is for 7000 series alloy. The increase in particle volume fraction decreases the crack growth rate, while for the aluminium 3.5 copper matrix with the silicon carbide reinforcement. So this composite, the effect of volume fraction is less on the crack growth rate. Means volume fraction is less effective in reducing crack growth. So Monir, your doubt is clear now or?
यस मैडम, डाउट इज क्लियर।
हाँ
और जो असाइनमेंट है उसमें 3 क्वेश्चन है, उसमें डाउट है।
हाँ असाइनमेंट है, अच्छा ठीक है,
हाँ,
मैं अभी असाइनमेंट शेयर करती हूँ। Can you see the assignment questions?
यस मैडम।
Yeah, so in which question do you have doubt?
Question number 6. Select the order per rate at which the crack grows in stage 2 type crack growth during footing loading.
Means you are saying about which option? Crack
Per cycle.
means sixth question you are talking about.
Yes madam.
हाँ so
वीक नंबर 12 का जो 6 क्वेश्चन है, सिलेक्ट द ऑर्डर पर रेट एट विच द क्रैक ग्रोज इन स्टेज 2 टाइप क्रैक ग्रोथ ड्यूरिंग द फटीग लोडिंग।
okay, during the fatigue loading. Okay, means this is not the assignment. So can you share your screen if you have that question? I will answer. I mistakenly took the previous week assignment. This is previous week or this week 12?
ये मैडम ये प्रीवियस वाला है। वन स्टेटमेंट इज स्ट्रेस कंट्रोल फटिंग इज वेट है मैडम। हाँ ये प्रीवियस वाला है मैडम।
ओके हाँ प्रीवियस वाला है, एक सेकंड में देखती हूँ।
Madam, my screen is visible.
Yeah, that's great.
Sixth question. Select the order per rate at which the crack grows in the stage 2 type crack growth during the fatigue loading.
Yeah, select the order or rate at which the crack grows in stage 2 type crack growth during fatigue loading. So this is I discussed in uh, week very week 9 or 10 lectures. Just checking. So it is in correct option is in nanometer per cycle,
Okay, madam.
or just I'm confirming the rate. Just wait for 2 minutes.
Okay, madam.
I think the correct option is nanometer per cycle is only. I have written it somewhere but not getting now.
Okay, madam. Okay.
Yes.
और ये जो सेकंड क्वेश्चन है द
हाँ,
फटीग रेजिस्टेंस और ऑफ DRMMCs at
हाँ.
plastic strain control fatigue condition is
Fatigue condition is uh, so fatigue resistance of DRMMCs in a strain controlled fatigue condition is the inferior than unreinforced alloy at low strain levels.
ओके मैडम। और ये लास्ट जो एक क्वेश्चन था जो विच ऑफ द फॉलोइंग इज और आर कैरेक्टरिस्टिक फीचर्स एसोसिएटेड विथ स्टेज 1 क्रैक ग्रोथ ड्यूरिंग द फटीग लोडिंग।
So the featureless fraction stage 1 crack growth, the featureless fraction surface stage 1 crack growth. Deepening of initial. First, stage 1 crack growth includes the deepening of the initial crack on planes of high shear stress.
ओके
And I think this has more than one answer. The last option is not correct. Crack tip blunting process. And one more. Striations on the fracture surface. Yes, so
crack growth on planes of high tensile stresses, fifth one,
fifth one. No,
sixth one.
this is the stage 2 crack growth. Yeah, so crack on planes of high shear stress, deepening of the initial crack. So this deepening of initial crack is correct. Slip band crack growth and the featureless surface. And crack growth, lower crack growth rate is nanometer per cycle. So in the sixth question, the growth rate will be in micrometer per cycle.
Okay.
And featureless fraction surface, lower growth rate, deepening of the initial crack on planes of high shear stress. Yeah, this is correct. For sixth option, you change the option.
Okay, madam. Okay, thank you, madam.
Thank you. And any more doubt you have?
नहीं मैडम, अभी तो डाउट नहीं है।
हाँ
और वन थिंग मैडम,
हाँ
जो एग्जाम वो एमसीक्यू बेस्ड रहेगी ना, या उसमें कुछ डिस्क्रिप्शन या डिस्क्रिप्टिव रहेगा?
डिस्क्रिप्टिव आई डोंट थिंक। एंड मेरी अभी प्रोफेसर से बात हुई नहीं है, तो मैं भी शायद जैसे असाइनमेंट है वैसे ही क्वेश्चंस होंगे। और कुछ क्वेश्चन उसमें न्यूमेरिकल बेस्ड भी थे इन प्रीवियस वीक्स।
यस मैडम।
उसमें कुछ कांटेक्ट एंगल वगैरह मेजर करना था, कांटेक्ट एंगल एंड सरफेस एनर्जी वाले छोटे न्यूमेरिकल क्वेश्चंस थे, तो वो आ सकते हैं। एंड मैंने शायद नेक्स्ट वीक एक कंक्लूडिंग सेशन भी रखा है, तो उसमें मैं जितना भी कोर्स में पढ़ा है तो उसका एक मतलब शॉर्ट ओवरव्यू दे दूँगी, मतलब अप टू वीक फ्रॉम द वीक 1 to week 12 लेक्चर, सो यू कैन आस्क द डाउट इन दैट ऑल्सो।
ओके मैडम। और मैडम वो डाउट क्लियरिंग सेशन ट्यूसडे ही होगा ना?
हाँ, ट्यूसडे ही होगा।
हाँ हाँ, ओके मैडम, ओके ओके, थैंक यू मैडम।